Hi guys, so we're gonna go ahead and review for the test that you guys have tomorrow and Thursday. So number one, triangle STU is an acute isosceles triangle. Determine the measure of each of the congruent sides. So for those of you who don't know, oh, and by the way, everything that I write, you should be writing, okay? So make sure you write down the question, write down, draw the picture as best as you can. So try to write down some really good notes. All right, so isosceles means that two sides are congruent. Okay? All right, so just from looking at it, I can already tell that these two sides are congruent. But I have to, it says determine the measure of each of the congruent sides. So I want the measurement of these sides. So there's two ways that you can do this. You can either do the distance formula to find the distance between point S and point, or sorry, not point S, point T and point U. Or you can do the Pythagorean theorem. The Pythagorean theorem, you're going to have to create um, lines like this. Okay, I'm gonna go ahead and do the distance formula just because I think it's easier that way. Okay, so this is the distance formula. And this was also in y'all's math. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, so this point is 0 comma 4. This point is 3 comma 0. And this point is negative 3 comma 0. So I'm going to find the distance of TU. Okay, so I'm going to label it. The first step is to label your points. Okay, so I'm going to label it x1, y1, and x2, y2. And then let's be specific. Label your points x1, y1, and x2, y2. Okay, so now that I labeled it, I can go ahead and plug it into the distance formula. So I'm going to have x2, which is number 3, minus x1, which is 0, squared, plus y2, which is 0, minus y1, which is 4. So 3 minus 0 is 3 squared. 0 minus 4 is negative 4 squared. 3 squared is 9. Negative 4 squared, if you type that into the calculator, you get 16. And then 9 plus 16 is 25. And the square root of 25, if you type it into your calculator, you get 5. Okay, so the distance between T and U is 5 units. And as you can tell, ST is also going to be 5 units because they are congruent, right? So my answer, whenever I type it in, it would just be 5 units. You're not adding the sides or anything. It's just asking, determine the measure of each of the congruent sides. So each side is 5 units. So that's how you do number one. You could have also done the Pythagorean theorem, okay? If you wanted to do the Pythagorean, oh, I already explained it. If you want to do the Pythagorean theorem, you have to draw the right triangle. And then if you forget a squared plus b squared equals c squared, okay? But I'm not going to do that. I like the distance formula better. Okay, what is the area of the given figure? So this is a square. If you draw right triangles, you get 1, 2, 3, 4, 4 here, and 1, 2, 3 here. And you do that all around. You get 1, 2, 3, 4, and 1, 2, 3. So that's how you can tell that this is a square because all the sides are the same. Okay. So the area of a square, and by the way, this was also in your mathia, is s squared. That means side squared. I'm gonna write that down. Side squared. So as long as you find one side, you just square that. Okay. So again, you can do the distance formula to find the two, or you can do the Pythagorean theorem. For this one, I'm going to do the Pythagorean theorem so that you guys can see both the distance and the Pythagorean theorem. So I'm going to draw a right triangle using auxiliary lines. Okay, so if I count this, this is 1, 2, 3. And this is 1, 2, 3, 4. So I'm going to do a squared plus b squared equals c squared. So that is 3 squared plus 4 squared equals c squared. So I get 6, or whoops, I'm sorry. I get 3 squared is 9, and 4 squared is 16. And 16 plus 9 is 25, is equal to c squared. And how do I get rid of the square? I take the square root of both sides, so I get that c is equal to 5. So that means that this is 5, this is 5, this is 5, this is 5, right? So remember that the area of a square is just side squared. So if I do 5 squared, I get 25. So the area would be 25 units. That's my answer. So that's how you would use the Pythagorean theorem. Okay. One thing I want to mention. Whenever you're taking the test and you have any graph, be really careful that each square represents 1 unit. Like for example, here, this was 1, this was 2, this was 3, this was 4, this was 5, 6, 7, 8, right? And same thing here on the y-axis, 1, 2, 3, 4, 5, because it's not always going to be like that. So you have to be really careful of that. All right, moving on. What is the perimeter of the given composite figure? So a composite figure means it's composed of triangles and rectangles. Okay, so what does that mean? That means that I can break it up into triangles and rectangles. And also remember, perimeter, no matter what shape you have, perimeter means that you add up all the sides. You add up all the sides. So I had to find JK. What is the length of JK? I have to find JR. I have to find QP. Oops. I have to find KL, ML, MN, and I'm forgetting one, RQ. Let's see if I got all of them. That was 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, I'm forgetting one. JK, JR, RQ, QP. Oh, NP. Okay, so some of these are really easy to count. Remember, make sure that it's going by ones. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Because sometimes it's going to go by 3, sometimes it's going to go by 2s. So you have to be careful, okay? So here, I'm just going to count. From J to K is easy to count. This is 1, 2, 3. I'm going to do all the easy ones first. From K to L is easy as well. I just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That was KL. Then I do ML, that's 1, 2, 3, 4, 5. MN, 1, 2, 3. NP, 1, 2. QP, 1, 2, 3, 4, 5, 6. And then I have JR. JR is hard, so I'm going to do that one last. RQ is 1, 2, 3. Okay, so JR is hard because it's slanted. So I can't just count the squares. It's at a diagonal, right? So again, you can either do the distance formula or you can do the Pythagorean theorem. So for this one, I'm going to go ahead and do the Pythagorean theorem. So I'm going to create my auxiliary lines. I have This is 2. 1, 2, 3. This is 3. So I'm going to do 2 squared plus 3 squared is equal to c squared. 2 squared is 4. 3 squared is 9. 9 plus 4 is 9, 10, 11, 13. And I take the square root of 13. Let me do this real quick on my calculator. Hold on, guys. Square root of 13 is 3.6. So now this is the easy part. I just add them all up. 3 plus 6 plus 11 plus 5 plus 3 plus 3 plus 2 plus 3.6. So we didn't even have to like break up the shape into triangles and rectangles because we're just counting around it, right? Okay, so let me go ahead and do that. 3 plus 6 plus 11 plus 5 plus 3 plus 3 plus 2 plus 3.6. So whenever you do that, you get 36.6 units. Okay? All right, moving on. Let's see if you guys, let me zoom in a little bit more. What transformations are considered isometric? So isometric means size and shape are preserved. So that means preserve means that it stays, the size and the shape stays the same. It does not change. So what transformations do we have? We have rotation. We have reflection. We have translation. We have dilation. So dilation, we didn't talk about it in class, but dilate means that it becomes bigger or smaller. Hopefully y'all can see that. So we have rotation, reflection, translation, dilation, and dilation means it becomes bigger or smaller. Am I forgetting one? No, I think that's it. Okay, so what transformations are considered isometric? So which ones does the size and shape not change? So for rotation, it doesn't change because all I'm doing is I'm rotating the shape, right? For translation, all I'm doing, so rotation means to spin. All I'm doing is spinning the shape. I'm not changing the size or the shape. Translation would be another one because all I'm doing is sliding. And then reflection will be another one because all I'm doing is flipping it. So spin, slide, and flip. That's rotation, translation, and reflection. So dilation is not isometric because if it's becoming bigger, that is changing the size. So it's not isometric. Okay, find the leg. Oh, I meant to put leg. Find the leg of the hypotenuse. Okay, so hypotenuse is the longest side of the triangle, the longest leg of the triangle, right? So hypotenuse means longest side of right triangle. So the longest side here is obviously AB. So I'm trying to find the length of AB. Again, it's not easy to find because it's slanted. So I'm going to either use a distance formula or I'm going to use the Pythagorean theorem. Okay, so again, look at the units. Is it going by ones? This is 0, 1, 2, 3, 4, 5, 6, 7. Good. And then 1, 2, 3, 4, 5, 6, 7. Good. So it's going by one, so we're good. All right, so you can either do the Pythagorean theorem. So you could either draw another right triangle, and then this is 2. This is this would be 1, 2, 3, 4, 5, 6, 7. You could do the Pythagorean theorem, or you could do the distance formula. I'm going to do the distance formula for this one because I want to practice using both, okay? So point A is negative 7 comma 2, and point B is negative 5 comma 9. So remember, the first thing to do is to label your point. Okay, so I'm going to label it x1, y1, and x2, y2. So now I'm gonna go ahead and plug it into the distance formula. So I have x2 minus x1 squared plus y2 minus y1 squared. So x2 is negative 7 minus, and you know what? Let me put that in parentheses. Negative 7 minus x1 is negative 5 squared plus y2. Y2 is 2 minus y1 is 9 squared. Okay, so negative 7 minus negative 5 is the same thing as negative 7 plus 5. So I get negative 2 squared. 2 minus 9 is negative 7 squared. And negative 2 squared is 4. Negative 7 squared is 49. 49 plus 4 is 53. And the square root of 53, type it into the calculator. You get 7.28. So there you go. 7.28 is my answer because that's the hypotenuse. This is my hypotenuse. That's the longest leg. Okay, and it's also, the hypotenuse is across from that right angle. Right? You could have also done the Pythagorean theorem. All right, number 6. Given AD is congruent to CB, so AD is congruent to CB, and ADB, so this one, is congruent to CBD, prove that DAB is congruent to BCD. So remember, we have angle, side angle, we have side angle, side, we have side, 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 and we have other ones, but these are like the main ones. Okay, so if I know that AD is congruent to DB, first of all, I know I have an angle and a side, so it's not going to be side, side, side. Do they share another angle? Because angle, side angle has 2 angles. No, they don't give me that they share another angle. So it must be side angle, side. Well, I have side, then I have angle. Now I need another side. Remember, we're focusing on one. So whenever you're doing these, focus on one. So I'm focusing only on this triangle right here. Okay? I'm only focusing on this triangle. So if I read it, I have side, angle, and I need a side. Well, I can tell here that they share DB. DB is congruent to BD. They share this side. So there you go. I have side, angle, and side. Remember here that the order matters. DB has to be congruent to BD. I cannot say DB is congruent to BD because the D has the angle and the B has the angle. So the D and the B have to go together. The B and the D have to go together. Okay. Okay, so they already gave me this and they gave me this. So I have side, angle, and then the one that I just found, side. So it's side, angle, side. So we can say triangles congruent by side, angle, side. All right, number 7. Prove that the triangles are congruent. If they are not congruent, state what is missing to prove that they are congruent. Okay. So remember, we're looking at one triangle at a time. So all my focus is going to be on this triangle. I'm going to focus only on this triangle. Okay, so I have angle NMP is congruent to what angle on the other triangle? It'll be NLP. And then we have MP is congruent to LP. So what do I need? Remember, I have side, angle, side. I have angle, side, angle. And I have side, side, side. So I already know it's not side, side, side because they don't give me three sides. They gave me a side and an angle. So it has to be one of these two. Now, is there any way for me to prove that they share a what's it called? Um, an angle? No, there's no way for me to prove that they share an angle. So it can be angle side angle because there's no two angles. I only have one. Now, could it be side angle side? Yes. If they show, so this doesn't show that it's congruent. So triangles, MPN and LPN are not congruent because they are missing information. Okay, so how could it be side angle side? They could be congruent if they gave us. Wait, actually, hold on. My bad, guys. Oh my god, I'm sorry. I'm sorry. They would be congruent. They would be congruent because they share a side. I'm sorry. They share this side. NP is congruent to NP. And this is by the reflexive property. This is by the reflexive property. So you can say MPN is congruent to triangle LPN. I'm sorry. I know y'all are going to hate me for that. Okay. So they are congruent because they share a side. They share NP. So it's oh wait, no. Oh my goodness. Okay. So they're not congruent because remember one of the ones that is a false shortcut was SSA or ASS or angle, 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 right? So this one, remember the order matters. So yes, it's true that NP is congruent to NP. So I have angle, side, side. And I forgot to put another one. I have angle, side, side. And that is one of the false shortcuts. So, my bad. Not congruent because ASS is a false shortcut. So remember that the order matters. Okay. So the order that you read it matters a lot. So you could have read it side, side, angle. That's still not one of them. Or you could have read it as ASS, which is the one that we can't use. Okay. All right. Last question. What is the equation of a line perpendicular to this equation that passes through this point? So step one, remember that perpendicular means opposite reciprocal slope. And parallel means same slope. So I'm going to focus on this one because I'm working with perpendicular, right? But you should also know that parallel means same slope because that's also going to be on your test. Okay, so step one is to identify your slope. So your slope is the number next to x, which is negative 2 over 5. Now, that's not the slope that I'm going to use because I have to flip it and change the sign. So it goes from negative to positive. So now step 2, and I ran out of space. So step 2 is going to be to label your point, and you label it x1, y1. Let me zoom in a little bit. X1, y1. So I labeled my point, and step 3 is to plug into point slope formula. Okay, so I have y minus y1 equals m, x minus x1. So I have y minus my y1 is negative 8 equals m. I'm using the 5 over 2. X minus x1 was 2. And then remember, you always have to, step 4 is to solve for y. You always have to take care of the parentheses first. So we're going to clean this up. Remember, whenever you see a negative and a minus next to each other, you make it positive. So this is going to become y plus 8 is equal to 5 over 2 x minus 2. And now I can go ahead and distribute. 5 over 2 times x is 5 over 2x. 5 over 2 times negative 2 is going to be negative 5. And then to get that x by itself, to get the y by itself, you subtract 8. So I get y equals 5 over 2 x, and then 8, 9, 10, 11, 12, 13 minus 13. This is my equation. Okay. All right, guys, that's all I have for the review video. It's only 8 questions. A lot of these questions are very similar. So make sure that you know the distance formula and the Pythagorean theorem and everything else that we went over, okay? Good luck tomorrow. And sorry for making the video so late.